Chandra? You are doing repair work, right?
Sir.
So which laptop you are doing now?
This one is Dell Precision 7720.
Dell
sir.
Precision. It's a Xeon processor, I think so, right?
Yes, sir.
Okay. This one, what is the model number?
7720, sir.
Dell Precision 7720.
Okay.
What is the issue in this?
First, this one is no power, sir.
Okay, no power. Means it's a short, right?
Short.
It was short.
Short in 19 volts.
Okay, 19 volts. Then what you rectified till now? So it's under progress, right? Process.
Sir. I replaced this MOSFET, sir.
MOSFET.
P-channel MOSFET.
It's a P-channel MOSFET. It was internally short, right?
Yes,
Okay.
sir. We replaced this one.
Okay, you didn't get big one, so that's why you are it from small one only
Sir.
for testing purpose.
Then we found short in 3 volts
Okay,
section, sir.
3 volts
We are not getting LDO.
LDO. Okay, that's why
That's why
you need to replace the IC now.
yes, sir.
Wow, it's very nice board. See, this is Dell 7720 motherboard. What's the motherboard model number?
LAE 321P, sir.
Oh, it has separate slot for NVIDIA graphics.
Graphics.
Very nice one. And here it has two. It's
Back side.
two more also. Wow, it's a total four RAM slots. Okay, what is the model number? Model number is LAE 321P 2016. It's a server board actually.
Yes, sir. This one.
Xeon processor would be there, I think so. So it is. Yes, it's a Xeon processor. It's a server board. Okay, it's really good. So now you found one problem, and the second one you are rectifying, right? It's
yes,
the 3.5 LDO is not generated, so that's why you are checking one by one.
Yes, sir.
Okay. So this one theoretically, what will be the working functions later we will do. So finally, you tell me the result. What it will happen? It will be ready or not, or find the result. Okay, we will be waiting. Till that, we will check theoretically how this server board will works. It's a Xeon processor. Till now, we not explained Xeon processor boards, right? So how it will work and what are the functions and what are the difference between normal processor and Xeon processor. Those things I am going to explain today. Okay. Welcome to Pavitra Laptop Care. See, today we are doing general discussion on server motherboard. What is that? LAE 321P. The motherboard model number is LA-E 321P. This is server motherboard. It contains two SSD. What it contains, everything we will discuss one by one. Okay. Let us start from the DC jack. Okay. Here is the DC jack. So how many pins are connected here? That we will check according to the schematic. Number 1 not connected. Number 2 is the PSID. 3, 4, 5, 6 are the ground. 7, 8, 9, 10 are the positive one, and last number 11 is the ground. Okay. See in the schematic. So not in the board. Here this one not connected. Okay. Here pin number 2 is the PSID. 3, 4, 5, 6 are the ground. 7, 8, 9, 10 are the positive one, and 11 is the ground. Okay. All positive will connected to the coil. See here is the coil. Here is the coil. So now what the voltage we will check. We will connect, and power supply positive is correct or not, that we will check. See, it's a connected. The voltage is taking here. See Chandra, it's a 19.5 volts connected. It's a milliamps. It's taking 15 only, right? So some issues is there. So but basic issue you already solved it. So here is the 19.5 volts. See 19.5 volts and the coil voltage, and here is the source. What MOSFET it is? P-channel MOSFET. MOSFET number is in the schematic. It's a first P-channel MOSFET PQ5. See here is the PQ5. So big one you didn't get, so that's why you altered with the small one, correct? So here is the source, and 1, 2, 3 are the source, and here is the gate, and here is the drain. So now the source voltages we are getting 19.6. What about gate according to the voltage divider? See, here is the voltage divider PR16 and PR22. So what will be the voltage? 9.7. Okay, practically how much we are getting, that we will check. So here is the gate. So the gate voltage is 9.4. Okay, so practically also we are getting 9.4. What is the theory? 9.7. Okay, little bit here and there will be there. So now source we are getting 19.6 and here is the 9.7. And what about drain? Drain is 19.6. So now it's a PQ5 is good, correct? So voltage is passing from the drain, source to drain. It's a PQ5. It's a P channel MOSFET. So here from here where it's going, see the schematic. This one named as DC in SS. So from here it's going to this MOSFET PQ701. 1 minute, we'll search PQ701. Yes, this is the MOSFET. See the DC in from the PQ5, it's entering to PQ701. That is a source. Source in the sense it's a P channel or N channel? Which channel? P channel. Yes. Source to drain forward will be there. Or drain to source.
P channel drain to source, sir.
Yes. Always P channel drain to source will be the forward. Okay. Now it's a forward or reverse?
Forward.
Forward. Right. See the DC in is entering to drain and then source. The gate voltage you calculate. Here actually some logic is there. Through that logic the gate voltage is coming. Maybe it's a CDIC, CD3301, right? So from there it's coming. So let us check practically what will be the voltage in this. So now the MOSFET is PQ701. So here is the source. Here is the drain. It's coming to drain. Drain is 19.6. So what about gate? Gate is here. So gate is 18.6. It's turning off actually. So okay, anyway, the source you will get the voltage. What is the voltage? 19.1. Because of this forward bias, you are getting the voltage here. So here somewhere that CDIC it's making off. What reason you have to think later. So generally I will explain what are the component and what it does. So now you are getting the CLR voltage or not, that we will check. Next to this it's entering to CLR. See, this is the CLR not. Check, it's a PR701. The schematic here only will be there. Next continuation is PR701. PR701. So now PR701, the voltage is 19.1. This 19.1 voltage is coming to the from the second MOSFET, second P channel MOSFET. It's a PQ701. Okay, here actually gate we need to check something wrong with the CDIC. It should be on, but it's turning off actually. Okay, here CLR voltage you are getting because of the forward bias and not sufficient voltage also coming to the gate, so that's why it's passing. So now see from here where it's going, all over the motherboard, correct? So 19.1 is there, no? All high MOSFET it's taking. So till here is the CLR section. Now the CLR is connected to the where? Charging IC section. So first where we have to check? We have to check the charging IC requirement. See, before moving to charging IC, first CDIC requirement, what are the pin voltage its output giving, those things we will note down. Okay, so in Excel if you note down, so it will be very useful to us. One by one I will check the voltage and you have to note down. Okay, Mr. Chandra. Okay, now it's a pin number 1 to 9. It's a CDIC, so it's very important IC. Okay, in charging section. So its total pin is 36. So one by one we will check. Finally we will discuss what are the voltage, where it's going, and so what the result it's giving. Okay, so now pin number 1, I will start from the pin number 1. So you have to note down. See, it's pin number 1. Now I will connect this. So what the amp it's taking? It's a 14 milliamp it's taking. Okay. So now I'll check and tell you the result. You check and you note down in the Excel. Will you do? Okay. So I will start from pin number 1. Pin number 1. Are you able to see? Okay, we'll take a position here. So pin number 1. So 19.6. Just need not to type that volts. So because this is volts only. So second one 7.5. Third one 0. Fourth one 3.5. Fifth one 0. 34 19.2. 35 18.9. Last one 36 0.05. Okay, this is CDIC requirement, CD3301. Okay, this is related to the charging IC. So okay, later we will discuss what are the voltage we are getting in this and what it functioning. So now next we will move to charging IC section. Charging IC requirement, what it would be, pin size. Now we are checking charging IC requirement. Okay, what are the pin and what are the voltages at present we are getting. So depending on that we will discuss finally and what will be the issue in this particular motherboard we will check. So now charging IC requirement, you are ready with the Excel? Okay. So now I will tell you one by one, then we check this. So this is the one, charging IC PU700. What is the charging IC number? BQ24780S. But here IC also is there and it's a P channel MOSFET also is there. In this condition, this BQ IC, how it will work? So we will check. So now the pin number note down. So now it's a pin number 1, 19.2, pin number 25, 5.7, pin number 26, 0.2, pin number 27, 0.2, pin number 28, 19.3. Okay, this charging IC receiving the input voltage. But let us check, later we will discuss what are the pins, what are the voltage and what are the result it will give and what it's supposed to be and what is the problem and what is the solution. Slowly we can discuss. Now charging IC over and CD IC over and DC jack also over. Next what we have to check? Step down IC. Okay, we will come to the step down IC. See, this one is, what is that? Step down IC. It gives 5 volts always, 3 volts always, 3 volts LDO and 5 volts LDO. Initially it was TPS 51225C, but you have put 51225 instead of C, correct? But as per the schematic, what is the IC? TPS
51285BR.
Okay, see that the TPS 51285. Instead of that, here in the motherboard it was used TPS 51225C. Okay, that one was gone, so that's why he replaced as TPS 51225. Actually, in case of C only we have to replace it. But you replaced, it's a 5, right? 225. So let us check what are the output it's giving. So it will turn it on or not, that we will check. Now we will take the pin configuration. Why both are same or both are different, those things we will discuss in the data sheet. Okay. So now pin number 1, 0.3, 18, 0, 19, 0, 20, 3.3. So these are the requirements. We are getting LDO 3.3 and 5 volts, but it's not triggering. Correct. See, the board is not triggering. If you press also, we are getting only 10 milliamps. 10 milliamps. So now what will be the result? We will check one by one. See, we got the IC requirements. What are the voltages it has? Using this, using the schematic, where is the exact fault? We can easily find out. Okay. Slowly we will check the schematic, we will discuss, and finally we come to the result. So this is the first server motherboard you are servicing, right? So first you rectified the V in section. Now V in section is good, but the thing is the second MOSFET CD is controlling. So because of that forward bias, the P channel, what is that MOSFET? So that's why you are getting CLR voltage 19.1. First we need to check that CDIC is good or not. Okay, because the gate voltage should come proper voltage. It will be less voltage, but it's near to the source voltage, right? So it should not be. So next thing is one main problem with the main CLR voltage, CD voltage. Second thing is in step down IC, the main IC TPS, what the number?
51285 sir.
125128.
TPS
TPS 51285. Instead of that, on the motherboard it was what?
51225 sir.
51225C. Correct. You replace it as only 5. So we will check the data sheet and what are the major difference. That also we have to see. The second fault is the IC. The step down IC should be C. Instead of C, we should not put the normal one. Okay, A or B, whatever it may be. Okay, that one is the main problem. Here, once we rectify these two, it may get rectified or not. We'll check tomorrow. Okay, so that's it today. So we'll start from the tomorrow class. Okay, thank you very much.